So now we have our work cut out for us. Okay, here is our differential equation, LC d squared v by dt squared plus v equals vi. Okay, let's go ahead and solve this. And we will use the same technique we've been using so far in this course. Okay, we just use the same method to solve all our differential equations. Okay, do you recall that method? Okay, it was the method of homogeneous and particular solutions. Recall the method had 3 steps. Okay, the first step of those 3 was to find the particular solution. Let's write that down. The second step of the method was to find the homogeneous solution. Here, there's going to be a slight variation. In finding the homogeneous solution, we are going to use 4 steps to do it. Okay, this will be a 4-step process. Okay, and then our third step is the usual third step of the method of homogeneous and particular solutions, which is to create the total solution, where the total solution is the sum of the particular and homogeneous solutions. And then you use the initial conditions to solve for the remaining constants. Okay, so let's go ahead and write that down for our notes. All right. 3 steps: find particular, find homogeneous solution, and then the total solution will be the sum of the particular and homogeneous, and then go ahead and find the remaining constants. So let's suppose that a particular solution is given by Vp of t, the homogeneous solution is given by Vh of t, and so then our total solution V is given by, V of t is given by Vp of t plus Vh of t. All right, so let's go ahead and let's go ahead and flesh out the problem a little bit more. So as you know, our differential equation is L squared d squared v by dt squared plus v equals vi. And why don't we say, let's pick the vi for which I will do the example solution. So why don't we go ahead and, as an example, what shall I do? Well, why don't I pick a step input? Okay, let's go ahead and pick a step input for vi. So let me draw out a step input for you. That's 0, this is vi, and here's my step input. Okay, where at time t equal to 0, the input value of the input vi steps from 0 to capital Vi volts. Okay, that's my step input. Let me also go and pick initial conditions for my 2 state variables, state variables v across the capacitor and the current through my inductor. Okay, so voltage across the capacitor at time t equal to 0 is 0, and let's say the current through the inductor at time t equal to 0 is also 0. So in other words, what I am looking for is the 0 state response, because my initial conditions for both my state variables, the current through the inductor and voltage across the capacitor, has been picked to be 0. Okay, so let's dive in and solve the problem. So again, 3 steps: particular, homogeneous, and then you sum the 2 and find the remaining unknowns. So the first step to solve my differential equation is to go find the particular solution. Okay, so recall the differential equation was LC d squared v by dt squared plus v equals vi. So particular solution is any solution to the following equation. So I take LC d squared vp by dt squared, where vp is my particular solution, plus vp is equal to vi, where vi is my input. So for the input vi, I've been told that for t greater than or equal to 0, my input vi is capital V, capital I. It's a step input, and so it is capital V, capital I. So I go ahead and put this value, substitute this value in, and so any solution, okay, any solution for any solution for Vp that satisfies the particular equation here will be a solution. Okay, so why don't you go try this out for yourselves, and let's go to the next video and I will work out the solution for you.